What we're going to do today is finish up the work we didn't get to finish when I had to call out sick on Wednesday. So, one of the kinds of inequalities that we didn't get a chance to review was compound inequalities. And so, compound inequalities work the same way as simple inequalities, except that now they have two sides. So, whatever we do in the middle has to be done to both the right and the left. And the same thing is true still that if we multiply or divide by a negative number, we're going to change signs. In this case, it means both inequality signs. So let's see what this one has to offer for us. So we have 1 is less than or equal to 6x minus 8, which is less than or equal to 4. So if we wanted to solve for x as an inequality to find our answer, we'd need to add 8. But if we add 8 to the middle, we have to add 8 to each side. And the thing to be really careful of here is to make sure you know exactly where your inequalities are, because sometimes I have students who will do the same action repeatedly to the middle because they're not realizing that it's the same expression and they miss where the inequalities are. So sometimes I will have students who find it easier to put it in parentheses so you see where the middle is. It's totally up to you if you want to do that, but it's just something to keep it straight so you know you don't lose anything. We have 1 plus 8 is now 9, which is less than or equal to, well, those 8's canceled out, which is what we wanted. 6x, which is now less than or equal to, 8 plus 4 is 12. Next step will be 6x is an x multiplied by 6, so we'll undo it by dividing by 6. So 9 over 6 is 3 halves, which is now less than or equal to x, which is less than or equal to 2. So in terms of inequality, that's our answer. If we drop it on a number line, it means that we have between 3 halves and 2, x is existing. We also know that x has to be between them and they have to be closed circles because it has the equal sign. And we also know that closed circles mean brackets in interval notation. So our interval notation would be bracket 3 halves until 2 and then another bracket. So the three different ways we could represent our solution is as an inequality, right? Inequality on a number line, and in interval notation. So same as before. So let's try one more. Now this one has a fraction in the middle, which in and of itself looks a little scary, but we can change things around a little bit and make it a little easier on ourselves by saying, okay, well, right now I have x minus 3 divided by a negative 3. And I can undo division with multiplication. So I'm going to multiply this whole thing times negative 3, which means I have to multiply the right and I have to multiply the left. It also means, don't forget, that we now have to change our inequality symbols. So negative 3 times negative 5 gives me 15, but now that is going to be this direction, and which is greater than, and then these negative 3's cancel out, so now I just have x minus 3 here. And now this one also goes this direction, and now I have negative 3. The beautiful thing about inequalities is right now I'm saying 15 is greater than x minus 3, which is greater than x, or sorry, is greater than negative 3. I can also take the entire inequality and flip it around to rewrite it as negative 3 is less than x minus 3, which is less than 15. That is the equivalent to reading from right to left. Negative 3 is less than x minus 3, which is also less than 15. And now this looks similar to the way that we've always seen compound inequalities. So from here we solve for x by adding 3 to all three sides. So we get 0 is less than x, which is less than 18, which means on a number line that we have x is between 0 and 18. So here's 0, here's 18, but these are open circles because it's not equal, which means we have parentheses, 0 to 18 in interval notation. Now if we hadn't, let's say we had not switched it around, and we left it as 15 is greater than x minus 3, which is greater than negative 3, could we still have gotten to the same place? And the answer is yes. Add 3, and we would get 18 is greater than x, which is greater than 0. That's still saying that x is between 0 and 18. You just have to be really careful with your signs. So it's saying x is between 0 and 18, because if we flip this one around, it'll be 0 is less than x is less than 18. So it's the same thing. So how do we solve quadratic inequalities? Well, these are going to be a little more challenging than linear inequalities just by the very nature of what a quadratic represents. Because of that square, things get a little more complicated. So we can use all of the tools that we've learned so far in this unit to help us out here. That's the nice thing. So we could use something like the concavity, where our x-intercepts are, where our vertex is. All of these things can help us figure out graphically what our linear inequality or our quadratic inequality looks like. So I said, for example, let's determine from the graph, which I gave you on the right, where is x squared minus 2x minus 15 greater than or equal to 0? Remember that greater than or equal to 0 means at or above 0, aka positive or 0. Which remember then means that if I'm looking at less than 0, means below 0 or negative, right? Below 0 or negative. So let's see what we've got. Where is x squared minus 2x minus 15 greater than or equal to 0? Well, that would be anywhere it is above the x-axis up here. So that would be all of this area up in here. Anything up in here is going to be positive. So where does my graph stay above the x-axis? Well, that is when x is from negative infinity up until this 0, which is at negative 3. And because we're including 0, we're going to put a bracket. And we have a union because it happens again starting at this 0, which is at 5. So 5 to positive infinity. And remember, our our interval notation is only talking about x values. So if we did it as an inequality, this is the same as saying x is less than or equal to negative 3, or x is greater than or equal to 5. That is saying the same thing. Versus the opposite. When is it negative? Well, that means anytime it's under the x-axis. Well, that would be everywhere between the zeros, which would mean between negative 3 and positive 5. So only between negative x equals negative 3 and x equals positive 5. But in this case, we're not going to have the brackets anymore, right? Because it's now just less than. So it would be parentheses. This is also where if we set it as an inequality, x would be between negative 3 and 5, but not including negative 3 and 5. So it would be just less than symbols, not less than or equal. So could we use what we know about concavity, our x-intercepts, and the vertex even to help us figure out our quadratic inequalities? And the answer is absolutely. We can even use a graph to check our work. So let's look at one. So for example, 7 says, solve for x, state your solution in interval notation, and show your solution on a number line. I want to know where x squared minus 2x minus 15 is less than or equal to 0. Well, this is where we want to find the zeros first, because that's what told us the most information on the last problem. So let's just set x squared minus 2x minus 15 equal to 0. Well, it multiplies to give me negative 15 and adds to give me negative 2. Hopefully you said x equals negative 5 and positive 3. So x minus 5 and x plus 3, which means that x minus 5 could be 0 or x plus 3 could be 0, which means x could be 5 or negative 3. So we know our inequality solution is going to involve a 5 and negative 3. So what else do we know about our function? Well, let's think of it this way. We know we have zeros at 5 and at -3. So at -3, right, and at 5, we know our graph crosses the x-axis. But what else do we know? X squared minus 2x minus 15, right? X squared minus 2x minus 15 is going to be concave up because a, the leading coefficient, is greater than 0. It's positive, which means if it's concave up, its vertex has to fall under this axis. So it has to look like this. So it has to be pointed up. And we want to know, where is it less than 0? Well, it's less than 0 anywhere down in here, right? Anywhere in between -3 and -5. So this whole piece of our graph between x equals -3 and -5 is where our function is less than 0. So we would go from -3 inclusive, right, with a bracket, to 5 inclusive because we have a less than or equal. And so we would have -3 to 5. We would know that -3 is less than or equal to x, less than or equal to 5. And on our number line, we would have our -3 and our 5. We would have closed circles and we would connect them. So we're going to try another one just to make sure we're getting the hang of this. So pause here and try this one on your own. This one says, I have x squared minus x minus 12, and I want to know, where is it positive? Not 0, but just positive. So pause for a moment. See if you can figure out, if nothing else, where your zeros are, your x-intercepts, and whether it is concave up or concave down. And then let's go from there. Hopefully you took a moment to pause and you were able to figure out that if x squared minus x minus 12 equals 0, where are our x-intercepts? Well, what multiplies to give me -12 adds to give me -1? Well, that would be -4 and a +3. So x minus 4, x plus 3. If we set x minus 4 equal to 0 and x plus 3 equal to 0, we know x is 4 or x is -3. So if we graph it one more time, now we have -3 again, and we know we have a 0 there, and we have a 4, and we have a 0 there. And let's talk about concavity. X squared minus x minus 12 is concave up because a is positive. So one more time, we're looking at something like this. And this time we want to know, where is it positive? So where is this graph positive? Anywhere above the x-axis. So all of these pieces up in here. Well, that is when x is -infinity, right, to -3. And now we're going to use parentheses because there's no equals. And it happens again, union, at 4 going to infinity. So that is just reading based on our domain and our function here. So all of these x's from -infinity all the way up until we get to -3. We skip over -3 to 4 because that's where it's negative instead of positive, and then we start again at 4, and that's where our graph is positive again. So before to positive infinity. In terms of inequalities, this is x is less than -3 or x is greater than 4. On a number line, this is going to look really interesting because we've got -3 with an open circle going to the left, and we have 4 with an open circle going to the right. So a little different than the one we looked at before. Example 9 says to solve for x and state our solution in interval notation and state it on a number line. But this time we have x squared plus x plus 2. Where is it greater than 0? So this one we'll have to find the zeros. So where is x squared plus x plus 2 equal to 0? Well, what multiplies to give me 2 and adds to give me 1? Nothing that I can think of. So we need to use the quadratic, right? Use the quadratic formula to find our intercepts. Here's the problem. If I look at the discriminant b squared minus 4ac, that gives me 1 squared minus 4 times 1 times 2. So I end up with 1 minus 8, which is a negative 7. This means that there are no real zeros. So there are no real zeros or intercepts, meaning our graph doesn't touch the x-axis. So if I have the x-axis, I also know that x squared plus x plus 2 is concave up again because a is positive. And it has no x-intercepts, which means the entire function is above the x-axis. So we would know that the entire graph, right, is above the x-axis, which means the entire graph is greater than or equal to 0. That's what it means. It's always positive is what we're saying here. So our entire graph, so this function, x squared plus x plus 2, is always positive. Always positive, which means our solution then would be negative infinity to infinity, or all real numbers, right? Or on a number line, literally it would just be the same number line, right? It would be all real numbers. This is a very special case of a quadratic inequality. Now, if I'd asked where was it less than 0, the answer would be no solution. There'd be nowhere because it's never under the x-axis. So our function never has a negative value. Let's try an example that's an application here. So a ball is thrown vertically upward with an initial velocity of 64 feet per second. The distance s in feet of the ball from the ground after t seconds is s of t equals negative 16t squared plus 64t. For what time t is the ball more than 60 feet above the ground? Well, let's think about it. What does this situation look like? Well, here's the ground, and let's throw the ball up. So it goes up and it comes back down. And we want to know for how long is it more than 60 feet? So maybe 60 feet somewhere in here. So maybe this is 60 feet, and this is the ground, which is 0 feet. Okay, so what we're really looking at here is where is negative 16t squared plus 64t greater than 60? That's what we're really looking for. Where is it above 60? Well, we need to move the 60 over then, and we have to solve. So we get negative 16t squared plus 64t minus 60 is greater than 0. So from here, we need to find the zeros of negative 16t squared plus 64t minus 60. So we're going to set it equal to 0, right? And I know we have to use a quadratic, but I don't like negatives, so I'm going to multiply everything by negative 1. So we end up with positive 16t squared minus 64t and plus 60 equaling 0. Because now the quadratic formula gets to be a bit easier. So now we know that t is negative 64 plus or minus the square root of negative 64 squared minus 4 times 16 times 60 all over 2 times 16. And if we were to figure out what's under the square root, that's going to be 16 squared. which is 256. So we end up with 64 plus or minus the square root of 256 all over 32, which is 64 plus or minus 16 all over 32. And if we solve for each one of those, we get t is 1.5 seconds and t is 2.5 seconds. Now the question is, are we looking at between them or on the outside of them? And the answer, it goes back to our graph. We know that we're looking for where this function is greater than 60. So we're looking for everything above here. And if this is 1.5 seconds and this is 2.5 seconds, then what we're really looking at is in between. So in the end, we would say the ball is more than 60 feet above the ground, right? Between 1.5 seconds and 2.5 seconds after launch. So that would be our answer, which means really that we've got 1.5 is less than t is less than 2.5. So 1.5 seconds is less than t, which is less than 2.5 seconds. So it's between 1.5 seconds and 2.5 seconds. And now that we've finished inequalities, you can go ahead and finish homework 10.